You are welcome. We are looking at quotient rule, finding the derivative of a function using quotient rule. So we'll be using this example to know how to go about the quotient rule, how to find the derivative using quotient rule, and when to apply the quotient rule when you're finding the derivative of a function. So the question is, use the quotient rule to find the derivative of k of x equals 5x squared all over 4x plus 3. So let's look at the solution and how to apply the quotient rule on this function. So firstly, we have to divide the expression into two. So we are using quotient rule and they are dividing. We have numerator and denominator in the expression. So we divide the expression into two, and I am using u and v to name the division of this expression. So for the u, we're having 5x squared, and for the v, we have 4x plus 3. So we divide the expression into two. Now we have a formula that we use or go by to use the quotient rule, which is du times v minus dv times u all over vx squared. So du times v minus dv times u all over vx squared, meaning we are supposed to find du, which is the derivative of u with respect to x, then dv, derivative of v with respect to x. We have our v already, we have our u already, then vx squared as our denominator for this equation. So now let's find these individual parameters, which is the du and dv. So we differentiate u, then we differentiate v. So with that, we differentiate u, which is 5x squared. So we separate the coefficient from x squared, which is 5. Then we bring 2 in front of x. We subtract 1 from the exponent, we're getting 2 minus 1. So therefore our du is 10x. So 5 times 2, which is 10, then 2 minus 1, which is 1. So we've gotten our du. So therefore we differentiate v, which is 4x plus 3, which is 4x plus 3. So we separate the coefficient from x. We bring the exponential in front, we subtract 1 from the exponent. Then we're having 4 as a dv. We're having 4 as dv. Finding the derivative of a constant is 0. So a constant, which is a number without any variable, finding the derivative of such constant is 0. So our dv is therefore 4. So we've gotten our du, we've gotten our dv. So now finding the derivative of this function, we state the quotient rule again, which is du times v minus dv times u all over v squared. All over v squared. So now let's do our substitutions. So our dv is 10x. So we substitute our dv, which is 10x. Then the v, which is 4x plus 3, we substitute that. Then our dv is 4. We brought that here too. Then our u is 5x squared. The one too is substituted. Then we know v to be 4x plus 3. So we bring that here, then we square it as the equation is asking us to do. So now we've done our substitutions. So it's left with bracket expansion, then simplification. So we expand all brackets, then we simplify. But take key note, we first touch the numerator first. Then we see if we are supposed to touch the denominator and see if we can cancel out certain common terms to get the simplified form. So we first touch the numerator, then we simplify and expand the bracket. So 10x times 4x, which is 40x squared. 10x times 3, which is 30x squared. Then 4 times 5x squared gave us 20x squared. So we left the denominator untouched. Now we have x squared here, we have x squared here, so we can group these like terms, then we simplify. So grouping the like terms, 40 minus 20 give us 20. Then we have our 30x. So therefore the derivative of this function will be 20x squared plus 30x all over 4x plus 3. All over 4x plus 3 all squared. So this will be the derivative for this function. So now here's another question. Pause the video, then solve to get the answer. So the problem is find the derivative of kx, which equals 3x plus 1 all over 4x minus 3. So since there is division, we will still use the quotient to find this derivative. So into the solution, we first divide the expression into 2. So we have our u, we have our v. So the u is 3x plus 1, v is 4x minus 3. So the quotient will state the u times v minus the v times u all over v squared. So we are supposed to find our du, then we are supposed to find our dv. So with the du, 3x plus 1, find the derivative of 3x plus 1. We're getting 3. We separate 3 from x, subtract 1 from the exponent, which is 0. Then x to the power 0 is 1. So therefore we have 3. Then the derivative of 1 is 0. So du is 3. Then now dv, which is 4x minus 3, separate 4 from x, subtract 1 from the exponential, then bring the exponential to multiply the x. So 1 minus 1 is 0. X to the power 0 is 1. Then find the derivative of 3 is 0. So therefore dv is equal to 4. So we've gotten our du, we've gotten our dv. So we now find the derivative of the function. So we do the necessary substitutions. So du, we found that we know our v. dv, we found that we know our u. Then we substitute them into this equation. So du is 3. We substitute that. Our v is 4x minus 3. We do that substitution too. Our dv is 4. Then our u is 3x plus 1. We do that substitution too. Then our v, which is 4x minus 3, we substitute that, then we square it. So now let's simplify, then expand this bracket. So after the expansion, we're having 3 times 4x, which is 12x. Then 3 times 3, which is 9. 4 times 3x, which is 12x. Then 4 times 1, which is 4. So now we've simplified this expression. That is the numerator. Now let's expand the bracket. So after expansion, we're having 12x minus 9 minus 12x minus 4. So minus 12x can cancel 12x. So these two cancels out, leaving us minus 9 minus 4, which is minus 13. So therefore, the derivative of the function is minus 13 all over 4x minus 3 all squared, all over 4x minus 3 all squared. So this is how we use the quotient tool to find the derivative of a function.